Hello and welcome to the AI Research Roundup. I'm your host, Alex. Today is May 9th, 2025. We're examining an ICLR conference paper from about 3.5 months ago, January 22nd, called Training on the Test Task Confounds Evaluation and Emergence. This paper looks at a tricky practice in training large language models, AIs that learn from lots of text. It's called Training on the Test Task, where knowledge about how a model will be tested, say the question formats, influences its training. The authors argue this isn't data leakage, but it seriously messes with benchmark evaluations, our standard tests, and claims about emergent capabilities, those surprising new skills. Okay, so the authors illustrate this with key plots. We see model performance on two benchmarks, MMLU, which stands for Massive Multitask Language Understanding, it's a broad language test, and GSM-8K for math problems. The top plots compare accuracy to pre-training compute, the initial training effort measured in flops or floating point operations. Newer models clearly outperform older ones. But then, the bottom plots reveal that after fine-tuning all models on specific task data, a focused retraining, this performance gap nearly disappears. This strongly suggests training on the test task is the confounding factor. Building on that idea of fine-tuning, these next plots really drive the point home. We're looking at the gain in accuracy after that adjustment, that fine-tuning on task-specific data for both the Massive Multitask Language Understanding and GSM-8K benchmarks. The blue dots represent older models, trained before November 2023, and the orange dots are newer ones. You can clearly see the older blue-dotted models generally show a much larger jump in accuracy after this fine-tuning. This suggests they hadn't seen as much task-specific training before, unlike the newer models. Alright, so to really dig into this, the researchers then focused specifically on those older models, the ones trained before November 2023. These next plots show their performance on Massive Multitask Language Understanding and GSM-8K. The blue dots represent their scores before any extra fine-tuning, and the orange dots are after they've been fine-tuned on the test task. In the top plots, there's a noticeable performance difference. That's what the theta hat value represents. But look at the bottom adjusted plots. After this fine-tuning, that performance difference almost completely vanishes. This strongly suggests that giving older models this task-specific training makes them behave like the newer ones. Okay. So building on how fine-tuning older models closes that gap, these next plots dig deeper into the Massive Multitask Language Understanding results. On the left, with standard multiple-choice questions, newer models still show an edge. That theta hat value of 0.068 indicates the performance difference. But in the middle plot, when they change to closed prompts, essentially fill-in-the-blank style questions, that difference virtually disappears. This strongly hints the newer model's advantage is tied to the multiple-choice format itself. The right plot, using a Breyer score, which measures how accurate a model's confidence in its answers is, still shows sharp performance jumps. Okay, so beyond just Massive Multitask Language Understanding, the researchers also looked at other benchmarks. These plots show results for ARC, that's the AI2 reasoning challenge for science questions, and HelloSwag, a common-sense reasoning test. On the left, with close or fill-in-the-blank evaluation, the performance difference, that theta hat value is tiny. But in the middle, when these are turned into multiple-choice questions, a large difference appears. Then, on the right, after that familiar fine-tuning adjustment on the task, this performance difference almost vanishes again. This really highlights how much the specific test format, like multiple-choice, matters. So this idea that the test format and task-specific training are so influential leads us to these next plots, which really quantify the impact on perceived progress. These charts visualize the Pareto front for both Massive Multitask Language Understanding and GSM-8K. A Pareto front here. It's like a curve showing the best performance achieved for a given amount of pre-training compute. That compute is measured in flops, or floating point operations per second. The unadjusted plots show a large green area of improvement, but after the fine-tuning adjustment, this area, representing actual progress, shrinks by about 6-fold. This powerfully illustrates how training on the test task can really overestimate recent advancements. So as those Pareto front visualizations dramatically showed, training on the test task can really skew our perception of progress. The main takeaway here is that much of the recent performance jump in newer large language models isn't necessarily from them being fundamentally more capable, but rather from being more specifically trained on the kinds of tasks they're tested on. The authors suggest a path forward, standardizing evaluations by fine-tuning all models on the same task-specific data. This approach would give us a much clearer picture of genuine advancements. That's all for this fascinating paper. Thanks for tuning in to the AI Research Roundup.